So let's talk about one of my favorite constraints, which happens to be the armature constraint. Now this shouldn't be confused with the armature modifier. They have a similar name, but they are different. So I've gone ahead and set up a little demonstration here. It's just a stretchy bone in the middle, which is a bendy bone, and we have a top and a bottom control. And this gives us the ability to rotate around and squash and stretch, and this bendy bone actually twists along with it. And what I want to show you is how to use the armature constraint to actually pin this owner bone to our target here. If you're wondering why our target bone is green, and that's because it already has the stretch to constraint on it, but that's not what I'm going to show you in this demo. I'm just going to reset everything, jump back to the front. So when we add the armature constraint, we want to do it on our owner bone. Now, at the time of this recording, you can't shift select and then select our target and hit Control Shift C and then choose the armature constraint, because it doesn't actually add the bones for us. It will add the constraint to the correct bone, but it's exactly the same thing as doing it the long way in the previous video that I showed you. So there's actually no fast way of doing it yet at the time of this recording. So I've just added it there. Now you notice that it's red, and that is because it's not set up properly. We actually have to add a target bone. So I'm going to click this, and then we get a little menu down here. I can open that up, and it says, what object do you want me to target? So I'm just going to click on here and then choose our armature object, and then we can put in the name of the bone. So I'm going to click in here and then choose the name of the bone that I want to target, which I've conveniently called target. So now that's set up, and that's all we need to do for this case. If I grab this and move it along, it's going to follow along with the bend as well as the twist of this bone here. So that is pretty awesome. So that makes it possible to do a lot of squash and stretch and have the controls follow along with the twist of the bone, which is something that you couldn't do in previous versions of Blender. I think this was added back in 2.8, but I'm not entirely sure. Let's have a look at a few more things here. So at the moment, I'm only targeting one bone, but we can actually target more bones. Now this isn't going to work properly, but I'm just going to say target the bottom bone there. So let's just choose a different one, and then we can actually weight them accordingly. So at the moment we have a weight of 1 on both of these bones, which means that they're not normalized. So I can click up here and you'll see that it has normalized those weights. It's going to follow along with our target bone 50% and follow along with our bottom bone 50%. And we can actually change this if we like. And then I can normalize that again, and that'll tell me the correct normalized weights rather than just changing it here, and that's not visually accurate. After you click normalize, that's going to show you the normalized values, which I think of as the true values. All right, so now what this means is if I move the bottom bone, you can see it's going to follow along 27.5%, and the rest is going to follow along mostly with the other one there. So it kind of does a little bit of both. So you can choose how much influence you have over the certain targets. But let me just delete that and try and reset everything back to 0. Now with these settings up here, I haven't actually played around with those yet, so I can't be of too much help for you. And there's one more thing that I want to show you before I let you run off and play around with this constraint yourself. And that is, you've got to be careful of the double transformations with this one. So if you're using the armature constraint, make sure that the bone does not have a parent. On here, relationships, it's not parented. Because if we do parent it, I'll just go ahead and do that now. Control P, let's just choose keep offset. And then we try and move it around. You see it follows along okay, but then when we move the parent, you've got double transformations happening. And that is not what we want. So the way to get around that is to make sure that it doesn't have a parent if you are using that constraint. So that is the armature constraint. It is awesome.